So far in our cluster architecture, we have seen API server and we have seen the nodes are working nodes and how to register these nodes with the API cluster. So now we are going to look into how to establish a communication between nodes and the control planes, and how the communication takes place between the nodes are working nodes and the control plane are the master plane. So this slide talks about the communication paths between the API server and the Kubernetes cluster. The intent is to allow users to customize their installation to harden the network configuration such that the cluster can be run on an untrusted network or on fully public IPs on a cloud provider. So node to control plane. Kubernetes has a hub and spoke API pattern. Hub and spoke API pattern. All API usage from nodes terminates at the API server. So none of the other control plane components are designed to expose remote services. The API server is configured to listen to remote connections on a secure HTTPS port, typically 443, with one or more forms of client authentication enabled. So one or more forms of authorization should be enabled, especially if anonymous requests or service account tokens are allowed. Nodes should be provisioned with the public root certificate for the cluster such that they can connect securely to the API server along with valid credentials. A good approach is that client credentials provided to the kubelet are in the form of a client certificate. So pods that wish to connect to the API server can do securely by leveraging a service account so that Kubernetes will automatically inject the public root certificate and a valid bearer token into the pod when it is instantiated. The Kubernetes service is configured with a virtual IP address that is redirected to the HTTPS endpoint on the API server. The control plane components also communicate with the API server over the secure port. As a result, the default operating mode for connections from the nodes and pods running on the nodes to the control plane is secured by default and can run over untrusted and or public networks. So now let's see control plane to node. So first we have seen a node to control plane. Now we will look into the control plane to the node. So there are two primary communication paths from the control plane to the nodes. So control plane is nothing but our API server to the nodes. The first is from the API server to the kubelet process which runs on each node in the cluster. The second is from the API server to any node, pod or service through the API server's proxy functionality. Again, I'll show you that. One is using kubelet, this part, and other one is using proxy. So now let's look into the API server to kubelet first. API server to kubelet. The connections from the API server to the kubelet are used for the main purpose of using this connection between API server to kubelet is fetching logs for pods. Second, attaching usually through kubectl, attaching to running pods, and third, providing the kubelets port forwarding functionality. So these connections terminate at the kubelet's HTTPS endpoint. By default, API server does not verify the kubelet's service or serving certificate, which makes the connection subject to man-in-the-middle attacks and unsafe to run over untrusted and or public networks. So to verify these connections, what we do is we use the kubelet certificate authority flag hyphen kubelet certificate authority. This flag, if you use this flag, we can basically verify the connection with the root certificate bundle to use to verify the kubelet serving certificate. Then if this is not possible, if this certification using certification is not possible, then we can go for SSH tunneling. SSH tunneling between the API server and kubelet if required to avoid connecting over an untrusted or public network. Finally, if neither works, kubelet authentication or authorization should be enabled to secure the kubelet API. And now let's look into the another type of communication, that is API server to nodes, pods, and services. The connection from API server to a node, pod, or service default to plain HTTP connections and are therefore neither authenticated nor encrypted. So they can be run over secure HTTPS connections by prefixing HTTPS colon to the node, pod, or service name in the API URL, but they will not validate the certificate provided by the HTTPS endpoint nor provide client credentials. So, while the connection will be encrypted, it will not provide any guarantees of integrity. So these connections are not currently safe to run over untrusted or public networks. So then we will look into SSH tunnels, because that is a secure way of connecting, making a communication or connecting between node to control plane. So that's the reason what we are going to do is we are going to look into this. So the Kubernetes support SSH tunnel to protect the control plane to nodes communication paths. In this configuration, the API server initiates an SSH tunnel to each node in the cluster, that to basically that connecting to the SSH server listening on port 22. We know this because throughout this course we have used this SSH tunnel so many times to connect with our EC2 instance. If you remember, if you do not know, kindly watch all our previous videos. Every video we are gonna do the same, and passes all traffic destined for a kubelet node, pod, or service through the tunnel. This tunnel ensures that the traffic is not exposed outside of the network in which the nodes are running.